Assalamualaikum and salam sejahtera. My name is Muhammad Shahrizad bin Abdullah. So in this video, our group will discuss on assignment engineering statistic, and our group were assigned to discuss on data from Lajak Kuruih-I. So this is our group members. First one is Muhammad Shahrizad bin Abdullah, Muhammad Rizwan bin Muhammad Zaini, Muhammad Afiq bin Aziz, and last one is Muhammad Fauzan bin Rusnan. In this video, there will be a summarized data, goodness of fit test, ANOVA analysis, and linear regression analysis. So for question A, the question asks to describe and summarize the sample data of your assigned Lajak Laku tablet, which produced in December 2020. So present the observation effectively in numerical, tabular, and graphical forms. So this is data given for Lajak Kuruih-I. From this data, we can summarize it by using pivot table. So this is the summarized data that we have using pivot table. So we can see here is evening, morning, and night. So we can find the count of number, sum of weight, sum of relative density, and sum of tensile strength. So from this table, I can summarize it into average of weight, average of relative density, average of tensile strength. This also using the pivot table. And then we can find the sample variance, standard deviation, maximum, and minimum. So to make it easy, I will focus on the weight first. So this is the tabular form. I group it into 310 until 320, 320 until 330, until 380 till 390. We can see the difference here is 10, 10, 10 until here 10. So after I make this table, I can plot the bar graph. So here we can easily see that the highest count is 340 until 350, which is here is 58. So for this table, this is the table that I have summarized again from the summarized data. So for example, the maximum of weight 389.48. So here maximum 389.48. So this is the data is taken from the summarized data. So same with the relative density. I group it into 83 and 84 because the difference of the value is very small. So here is only one difference, 83 and 84, 84 and 85, so until 94 until 95. So I make the bar graph. So we can see the highest count is between 88 till 89 of relative density. So here is 45. So same with weight. This table was the summarized from the summarized data. So for tensile strength, I use the same method like weight and relative density. This is the tabular form because of the difference is very small. So here I choose to use 0.2. The difference is 0.2. Let's say that 65 until 67, 6.5 until 6.7, 6.7 until 6.9, until 7.5 to 7.7. So I use this table to create this bar graph. We can see the highest count is 7.1 until 7.3. Here is 85. So this table is the summarized data from the summarized data.
Hi, my name is Muhammad Rizwan bin Muhammad Zaini, and I am going to explain on the part B. Okay, based on the part B, the question has given me the mean value of 250 and also the standard deviation of 40. So it asks on to comment whether it is follow the significant evidence that the Lajak table produce follow the mean and the standard deviation given. So I am going to calculate it using the goodness fit test. Okay, based on the goodness fitness test by using the mean 350 and also standard deviation 14. My hypothesis is the weight of the standard tablet follow the normal distribution with mean 350 and the standard deviation 14. And the null hypothesis is it does not follow the normal distribution with mean 350 and also standard deviation 14. So that is my hypothesis. By the test statistic, I using my Excel table. So I can make this frequency table and I add up, it become 200. And this 200 will become the N. And then I'm using this table, OI, PI. This value I get from the statistical book table. And because the value here is 3.24, it is less than 5. I need to add up 5 with 9 to become 15.28 because the condition of EI, it must be more than 5. So after that, I get all the value here more than 5. So I will get row, the row 6 row. So by using the equation of goodness fit test, I add up, I get 3.0228. And then by the decision rule, alpha significant level 0.05, V, K is 6 because the row is become 6, and based on the critical point, based on the book I get 11.0705. So the condition is I will reject the hypothesis if the test value more than the critical point. However, because the test value is less than the critical point, I fail to reject H naught. So this means I conclude that the weight of the standard tablet follow the normal distribution with mean 350 and standard deviation 14 at alpha 0.05. Thank you very much.
Assalamualaikum. My name is Muhammad Fib Aziz and I'm going to explain on part C. Comment on whether there is any significant difference between tablet weights in milligram from the different shift. So here is the data for the tablet morning, evening and night. First we make the hypothesis statement. H naught, there is no significant difference in tablet weights in milligram from the different shift at a 5% level of significance, and H1, there is significant difference in tablet weight in milligram from the different shift at a 5% level of significance. We can also write the H naught as mu1 equal to mu2 equal to mu3, and H1 is mu1 must not equal to mu j for at least one I j, and I must not equal to j. So we reject H naught if the p value is less than the alpha at 5% significant difference. So the summary from the given data, we tabulate the group, the count for each group, sum, mean and the variance. The next is ANOVA. The first column is source of variation. Second is sum squared, degree of freedom, mean squared, F calculated, p value and the F critical. So the p value here is 0.7431. Since the p value is bigger than alpha at 0.05, hence we fail to reject H naught because we decide that we reject H naught if p value is less than alpha. Here, p value is bigger than alpha. So we conclude that there is no significant difference in tablet weights in milligram from the different shift at 5% level of significance. So next is part D. Thank you.
Hello, my name is Muhammad Fauzan Birusnan, and I will be presenting about the part D on regression analysis. So the question on part D is tablet hardness can be represented by its relative density and tensile strength. Studies have indicated that its tensile strength depends on the relative density regardless of production shift. Recently, a batch was found to produce a cluster of tablets that show low relative density value of 68%, 74.3%, and 81.1%. And based on the current data in December 2020, what is the predictions of tensile strength for such tablets? Comment on validity of the model that you have used to carry out this prediction. So for this data, the prediction was made by the model of linear regression analysis. Okay. Uh, about this linear regression analysis, there is a relationship between one or more response variable or one or more predictor variables. Okay. So the response variable are also called dependent variable, which is in this case tensile strengths, while the predictor variable are also are called independent variable, which is relative density in this case. So the equation to describe this relationship is y equal to mx plus c. Okay, this is the linear equation coefficient. Y for the tensile strength of pill in megapascal, m is the gradient of the line, and x is the relative density of the pill in percent, while c is the intercept. So this is the chart that obtained from the data given. You can see the tensile strength on the y-axis, while the relative density is on the x-axis. And in the middle of the chart, you can see the red dot lines, which is equal to the predicted tensile strengths. Uh, the equations of the red line that are obtained from the data is y equal to 0.0775x plus 0.2779. So to get the sorry uh, to get the tensile strengths of the relative densities given is just substituting into the x on the equations. So for 68, be substituted in the equation, you can get the tensile strength of 5.5479 megapascal, and for the 74.3%, you get the tensile strength of 6.0362 megapascal, and lastly for 81.1%, you can get the tensile strength of 6.4857 megapascal. Okay, that's all.